Hello and welcome back for Chapter 6, Lesson 6, Special Products of Binomials. So the objective for today is to find special products of binomials. So let's kind of look at what this looks like. This is just a visual, visual aid to help think about. Imagine a square with side lengths of a plus b. So here, this is a square, right? It has a and it has a b here, so you'd go a plus b. So that means this whole side length is a plus b. Then over here on this side, it is the same. This is a and this is b, so this side length would be a plus b. So if we wanted to actually take the area, remember the area of a square rectangle is just length times width. So the area of this square would end up being a plus b times a plus b. A plus b times a plus b, or that would mean the quantity a plus b squared, right? Because there's two of them and they're multiplied by each other. So the area of the square can be found by adding the areas of the smaller squares and the rectangles inside. So the sum of the areas would be this right here. And let me show you. So we have this, right? This is the area of the square, a plus b, and squared. And so we're going to find it in a different form, okay? So what we're looking at is if we look at this square, right? Well, what is the area of this individual square here? Well, it would be this a and that a, because it's length times width. So a times a is a squared. So that's what this would be. This represents a squared. Okay? Then what we're going to do is we're going to look at this other rectangle here. Now this rectangle, this has the width of b and the length of a. So if you want to find the area of this rectangle would be AB. And then we have this rectangle here, which has a width of b and a length of a, right? So this would be length times width, or a times b, and the area of this rectangle would be AB. And then lastly, we have this. And see how all of these rectangles and squares make up this entire square? Okay, that means that all of these added up is going to equal the area of the entire square. So if we look at this one, this has a length of b and a width of b, so it's the area of it would be b squared. So if we go ahead and we add all those things up, this a squared plus this AB plus this AB plus b squared, you would get the area, which would end up being a squared plus 2ab plus b squared. Now this equals a plus b squared. They're the same thing, right? So look at that. What's happening? If we find we have a plus b and that's squared, it seems like it's taking this a and it squares it, and it takes this b and squares it. But then it looks like they multiply this by this, a times b, which is that, and then they do it again, a times b, which is that, and that's where you get this 2ab from, okay? Now, the only reason why I'm going over this and the way that it looks is eventually in next chapter, you'll be given this, and what you're going to have to do is find and go backwards, and the answer will be this. So, whenever you know that you're dealing with one of these and you need to go backwards, you look at this and this is squared, like a squared, and you look at this number and it's a squared number, and then the combination is 2 times, because there's 2 of them, AB. So 2AB. So for instance, for example, if I needed to, let's say I had 7 squared, we'll call that 7, wait, hold on, not that. Okay, let's say I had 49x squared plus plus 4. And then this would be 28x. Okay, so let's say I have this. So what I'm asking myself is, hey, is this a squared number? And yeah, this is, 49 is the same thing as 7 squared, and this is x squared. So this is really this, okay? Then I want to ask myself, is this a squared number? And the answer is yes, this is 2 squared, right? And so then I want to say, well, hey, is this number 2 times a times b? So ab times 2. So basically you go 7x times 2, which is 14x, and then you multiply that by 2, which is, it would be 2 times 14x, which is 28. So what this means is we know that we're dealing with this perfect square, so then we can just take this a and that b, right? A, b, this is our a, this is our b, and we just go like this, 7x plus 2 squared. And then that's how you do the reverse, okay? So that's the only reason why I'm going over this, is so that you will notice that this is a squared number, this is a squared number, and then this middle one is 2 times 7x times 2, which is 28. And then you know, oh, hey, I can just go 7x plus 2 and then square it, and that's the backwards way to do it. All right, cool. But for the most part, we're not talking about the backwards part. That's going to be next chapter. We're just saying, hey, we can see this a plus b, it's squared. We know it's a squared plus b squared plus 2ab in the middle right there, okay? And it's really just the same thing as adding all of these individual rectangles up. Okay, let's look at the same problem, but we're going to look at solving it a different way. So we kind of got that like visual theory on why this is equal to this, okay? But one of the ways that I like to do it is just by writing it out. So a plus b squared, right? I'm just going to write that as a plus b and a plus b, right? Because it's just squared. And then I just like to do FOIL, use the distributive property twice. So a times a is a squared. And then we're going to do the outside. A times b is ab. And then the inside, b times a is ab. And b times b is b squared. And then we end up, once those come together, we get a squared plus 2ab plus b squared, which is what we were already talking about in the last slide. So this says a trinomial of the form a squared plus 2ab plus b squared is called a perfect square trinomial. So a perfect square trinomial is a trinomial that is the result of squaring a binomial. So this is our binomial that's squared, and what you get is it gets a perfect squared trinomial is what this is, where this is squared, and then this middle term is 2ab. Okay, so let's go ahead and look at some problems. So here, let's start with A, okay? So I see this here, and what I'm going to do to solve this is just write it out, x plus 3, and then use the distributive property or FOIL, right? First, x times x equals x squared. X times 3 is 3x. And then distribute the 3 to both of these, which is the inside and the last. 3 times x is 3x. 3 times 3 is 9. So you see we're getting that there's 2 of those. So you just add them together, plus 9. And if you look, we have our squared number here. 9 is a squared number, 3 squared. And if you take x times 3, which is 3x, and then multiply it by 2, you get that middle number. So this is a perfect square trinomial. Okay? Let's go ahead and look at this next one right here. It's a little bit more complicated, but I'm just going to do the same thing. I'm going to write it out. For 4s plus 3t squared. Well, I'm writing it out, aren't I? Okay, 4s plus 3t. Okay, now I'm just going to do FOIL, do the distributive property twice. So we're going to go 4s times 4s. That is 4s squared. And then 4s times 3t. I'm going to do the numbers. 4 times 3 is 12. And then it's just st. And then we do distributive property twice here. 3t times 4s. 3 times 4 is 12. And then it's just st. And then lastly, 3t times 3t. The last one, 3 times 3 is 9. And t times t is t squared. Okay, and then we just simplify 4s squared, 12st plus 12st, combine like terms there, which is 24st plus 9t squared. And that is it. If you look here, 4s squared, that 4 is a squared number, s squared is a squared number, 9 is a squared number, t squared is a squared number. And if you broke this down, this would be 2s and this would be 3t. And if you went 2s times 3t, that would be 2 times 3 is 6st, and then multiply that by 2, you would not get 24. What happened here? Oh, 4 times 4, this is supposed to be 16. Okay, this is 16. I'm sorry, I messed that up. Well, good. I'm glad I checked it. You guys are probably looking at 4s times 4s is not 4. 4s times 4s is 16. Oh, I made a boo-boo. Okay, so that was good. I checked it because I noticed that I did something wrong because it's supposed to be a perfect square trinomial. So let's see. Okay, so this is 4 squared, right? So this would be 4s, and this would be 3t, and so you'd go 4 times 3, which would be 12, right? And times it by 2, it would be 12st, times it by 2, you get that 24st. So this is a perfect square trinomial. And if you look, I mean, a perfect square binomial. And if you look there, there's the binomial and it's squared. Okay, let's look at C. Okay, so I'm just going to write this out. This is the same thing as 5 plus m squared and 5 plus m squared. Okay, now we're just going to do FOIL. So 5 times 5, right, is 25. And then 5 times m squared is 5m squared. And then we distributed that twice, so now we distribute the m squared twice. M squared times 5 is 5m squared, and m squared times m squared would be m to the 4th. Okay, so then we just combine like terms. So we have 25 plus 10m squared plus m to the 4th, okay, which is our answer. And if we want to check it, 25, that's a squared number, right? That's the same thing as 5 squared. And then m to the 4th is a squared number. That's the same thing as m squared squared, right? So we just need to check. It's going to be 5 times the m squared times 2. And 2 times 5 is 10 m squared. So yes, this is a perfect square trinomial. Okay, now it is your turn, ladies and gentlemen. I want you to go ahead and check it out with example 1. I want you to try A, B, and C, okay? So here is, my friend, the pause dragon. Remind you to pause your device. Go ahead and work all 3 of those out. When you get done, press play and we'll talk about them. All right, see you in a bit. Okay, let's see how you did. So this is going to be x plus 6, and then we just FOIL it, right? X times x is x squared, x times 6 is 6x. Then we go to the bottom, 6x is 6x, 6 times 6 is 36. And we have x squared plus 12x plus 36. And that is our answer. So if you got that one right, great job. Let's go ahead and look at B. So for b, this is going to be 5a plus b, 5a plus b, and then we just, FOIL it or distributive property twice. So right here, 5a times 5a is 25a squared. 5a times b is going to be a positive 5ab. Then we go here, b times 5a is going to be another 5ab, and then finally b times b is b squared. So then we just combine like terms. We get 25a squared. That's going to be 10ab plus b squared. So if you got that one right, awesome, awesome. Okay, on to this last one. Let's see how you did. So I'm going to rewrite this. Oh, not like that, like this. Okay. There. Okay, so we're just going to do FOIL. 1 times 1 is 1. And then 1 times c cubed is just going to be c cubed. Then we're going to go down here. C cubed times 1 is just c cubed. And then c cubed times c cubed, which is going to be a positive c to the 6th power. Then we just combine like terms. C cubed plus c cubed is 2c cubed plus c to the 6th power. And that is it. So if you got that answer, yo, gorenki mashita, you did a wonderful job, and I'll see you in a little bit for example 2.